Good morning. Myself, Vijay Krishna from Mechanical Department. Today I'm going to explain Lamis Theorem kit. So it was one of the experiment in active learning lab for first year mechanical engineering student. So what is the objective of doing this experiment? Using Lamis Theorem kit, we can find out the unknown mass. So using angle method, we are going to find that. So first I'd like to explain about the Lamis theorem kit. So this is the whole frame, and we are having two pulleys over which the thread is passed, and left and right hand side two known mass is suspended, and middle one. So this is going to be a unknown mass. So this unknown mass we are going to find out using a Lamis theorem concept. So this kit we are represented in the free body diagram. So this point is represented on Q, and this point represented as R, and this point we are going to represent as P. The angle between P and Q we taken as alpha. The angle between Q and R we taken as beta. The angle between P and R we have took gamma. So now we should know the value of alpha, gamma, beta. So alpha value, so alpha is the region between P and Q. So from this point to this point, it takes the angle of 90 degree. And if we add plus theta 1, we'll get the alpha value. And gamma, so gamma is between P and R. So from this point to this point, we'll get a 90 degree. And plus if we add theta 2, so 90 plus theta 2 will give a gamma value, and beta is between Q and R. So this angle we have to get means this is nothing but 180 minus sum of theta 1 plus theta 2. So if you know the value of theta 1 and theta 2, we can able to find out the unknown mass. So for finding theta 1 and theta 2, we are using an instrument that is an angle finder. So this instrument we are using in the active learning lab for finding angles. For example, if we take my hand is in the horizontal position. So if I keep this angle finder, it gives the value of 0 degree. So now our objective is to find out the angle. So which angle we are going to find out means, for example, consider this as a horizontal reference line. So I just kept over here. So the angle between this horizontal reference line and the inclined thread, that gives a value of theta 1. That is also represented in the free body diagram. And parallelly, this horizontal reference line and this inclined thread will give the value of theta 2. Now we have to find out theta 1 and theta 2 using angle finder. So now we can see that the needle is in the vertical position. Just if I tilt, you can notice that the needle is shifting from its origin place. Now I'm just placing my angle finder here, and I'm just measuring the angle. We can notice that the needle is shifted and it gives the value of 30 degree. So theta 1. So this angle gives the value of 30 degree. And parallelly, we can keep here also, we can measure theta 2. So it gives the value of 28 degree. So once we know theta 1 and theta 2, we can find out the value of alpha, gamma and beta, because alpha equal to 90 plus theta 1. So 90 plus 30 will give 120 degree, and gamma is 90 plus theta 2. So 90 plus 28 will give 118 degree, and beta is 180 minus sum of theta 1 plus theta 2. So sum of theta 1 plus theta 2 is 58. So therefore 180 minus 58, that gives 122 degree. So beta value is 122 degree. So according to Lamis theorem, we know that P by sine beta, Q by sine gamma, R by sine alpha. So in this case, P is the unknown weight. So for finding this unknown weight, we can take a relation P by sine beta equal to Q by sine gamma, or P by sine beta equal to R by sine alpha. So I am going to take P by sine beta equal to Q by sine gamma. So P is the unknown weight. This weight, P, this weight we are going to find out, that we are going to identify with the help of P. And sine beta, beta value we got 122, and Q. So Q is, we can measure from the kit, that is the suspended mass. So the total mass of is going to be 100 gram, because here totally we have 5 cells, each carries 20 grams. So 5 into 20, 100 gram. So 100 gram divided by sine gamma. So that is 118 degree. So if we substitute the values, so let's see, sine 122 equal to 0.84 equal to 100 divided by sine 118 is 0.88. So if you substitute, we'll see what is the value we are getting. So 100 into 0.84 divided by 0.88. So that is 95.45 gram. So the P value, okay, the P value using Lamis theorem, we got 95.45 gram. So the middle weight we have achieved using Lamis theorem is around 95.45. So that is the usage of this kit. So that's it. Thank you.